then you all got to finish off the extra quadratic practice as a group. We said, nah, we should get a little more with that, right? And I'm pretty sure I already had all the answers up there for you. We're all good with that. So before we head to 3-6, y'all, you owe me a daily check on that stuff. Mwahaha. So 3-5 was graphing quadratics. Oh, no, wrong class. Okay, I would like you to graph this. If, I want to repeat myself here, if your ability to make a decent graph is hampered by your atrocious handwriting, I would recommend on that 3-5B, there are a couple of those graphs that we did not use. I think the bottom left corner one will fit this perfectly. Okay. On that practice page we just did last time, 3-5B, I'm pretty sure that bottom left corner 10, that graph fits this perfectly. So if you want to do it there, and then you just make sure that you like highlight it, put a box around it, something, so I know your daily check is on that page. Or if you got graph paper in the back, maybe you already grabbed a page. I was content until Sean walked in. Now you got to move. So if you want to do it on graph paper, if you're good enough making your own graph and you're going to be neat enough that we can see where the points are, you're not just BSing it. Or if you want to do it on one of those empty graphs on 3-5B, I don't care. What I do care about is you have the table next to this, you graph it, and then tell me whether it has a minimum or maximum, what that minimum or maximum is, what zeros might it have. Because remember, some of them didn't even hit the x-axis. Okay? So I want you to do that stuff and have your table shown. You do that, then we'll get going on 3-6. 3-6 is short, and I'm pretty sure we even started talking about it already. So you'll have time to work today and finish.
But you haven't seen as much money in your life to have as you need it. You get it, or is that your mama's?
What?
Is that your mama's credit card?
No, it's mine. It says mortgage, but they don't have one.
Oh, yeah. Oh, I was in Nigeria. Shit, you got like $5 on that?
What?
You got like $5 on that?
No, I had like 200, but then I lost my shoes.
I need to put shoes.
What? Yeah, look at your ugly shoes. So ugly. These shoes right now are expensive.
Because I'm 270s.
Dude, 270s are on like $180 bucks.
Not my money.
Fair enough. My parents bought these. These are $200. These are comfy. They're not good.
They do it for your ankles.
Oh yeah. If you go one way like that, she's gone.
Okay, we kind of beat these things to death. I don't think it'll take us too long. Remember, we want minimum 5 points so we can see our curve. Use your calculator to do the work for you. Use parentheses. Don't pull a freshman and swap your X's and Y's. I don't know. That's right. Harley, I got a rag. The rag so I don't have to go around you. Thank you. Because no, we will not be saving Ezekiel. Okay. While the last few are finishing up, the day approaches. Mama Bear has requested what the requests for this year will be. We are close to Pi Day. Y'all ever actually done anything for Pi Day in any of your classes? pi about 3.1415926 or about 22/7 is March 14th every year. And every year, Mama Bear makes pie. Okay? It's interesting that none of you coming into this class heard from previous classes how this goes. Mama Bear makes pie. It's usually in the order of 16 to 25 pies. We just line the counter. She gets a kick out of it. Kids like it. There are past choices on the back if anyone has something else that they would like. But it's just something that my wife has always done for my classes. I used to just go get a pie. I think I did that once. I went and got a pie from a store. I brought it into class for my geometry, and then my wife got offended that I went and bought a pie, and she's been doing this ever since. Like I walk in with a laundry basket full of pies. Okay? So, if anyone has any dietary restrictions, if you need gluten-free, we usually make sure we got a couple of gluten-free crusts, different types. If anyone is like egg or lactose-free, anything like that, let me know about food allergies, okay? Let me know. But I would like, if you would, at some point before Tuesday, because that's when she's going to go get all the stuff for it, you put 3 tallies next to your number 1 choice, 2 tallies next to your second choice, 1 tally next to your third choice. That way, it allows me to see how popular the different ones are, so I can let her know we need 3 of this kind, we need 2 of this kind, we need 4 of this kind. Okay? Yes. It's basically like fluffy chocolate pudding in a pie. Okay? If there's anyone who just hates pie, the cookie pie is basically just a big honking cookie. Like it's literally like a 10-inch wide cookie. Okay? So if anyone just hates pie, that's your jam. If anyone is a texture eater, I can't eat anything up there besides the cookie pie, and the pumpkin pie is grandma's recipe that she came up with for the texture eating oddest in the family who can't eat any of that goo. That pumpkin pie is made with, like, you mix up all the stuff in a blender instead. And when you cook it in the pan, it comes out with the consistency of a brownie. Like you can just hold the slice of pie in your hand and eat that. Grandma came up with that. It is amazing. My wife has perfected the recipe. It is good. Okay. So sometime in the next couple of days, if you want to put what your choices are up there, or if you have any restrictions, great. It's just something we like to do for shiggles every pie day. Okay. Over here, your table should look something like this. Okay, you should have at least 5 of those points in your table. Okay, now I know we might have goofed something. It's about the process. Your graph should look kind of like this. Okay, so table and graph. From this, does this thing have a minimum or a maximum? A high point or a low point? Okay, so I would say it has a minimum of how low does it go? -4. And I would say it's at x equals 0, just like we were doing the other day. The zeros, what are zeros again? Where it hits the x-axis. Okay, so I'll say my zeros are at, you can either say them separately or, neat little math trick, you say plus or minus 2. So you should have, you said it was a minimum, you said where, you have your zeros, you have your table, and your graph matches it. Yes, ma'am.
So I put the coordinate for minimum and max.
Oh, that's cool too.
Okay.
Yeah. Because you still said what they were.
Okay.
Okay, now, if you goofed, like say you missed the parentheses when you were putting stuff in, what if you said x squared plus 4? You just brain farted and put plus 4. Anyone have something like that go on? Like if I said x squared plus 4, I'd have all those same points, they would just be from 4 going up. You'd have a minimum of 4 at x equals 0. You would have no zeros, and your table would look different. I would just call that one off because you just missed plus instead of minus. Okay? So if you're not sure about the scoring on these, ask. Always score them. Some of you are just writing a problem and not doing anything with it. Always score them. Okay? Make sure it's labeled. If you wrote it somewhere else besides the back of the packet, make sure I can find it. Labeled, highlighted, something. It's obvious that your daily check is here. And then you should be good to go. All right, so we did our quadratic stuff. Come on, you. Then we did extra day of practice, and then we started this, right?
Yeah.
It was, what was that, a late start, or?
No,
We were just kind of thrown off, right? Okay. So the idea behind these is that every single graph I have is a transformation of the parent. Think like the matriarch of the family. Every one of you is some sort of genetic twist on grandma. Every one of you came from grandma. Some parts of you. And then you just kept dumping stuff in the bowl and mixing it around. Okay? There were transformations to that genetic code, especially for all of our sophomores who are in biology. Okay? Our transformations for our graph, we all wrote it here. Did everyone actually put it? I hope. Was that if I start with a line, which is just good old y equals x, that's grandma, that's the matriarch, that's the parent function. I'm going to change it by saying y equals x plus c. And because that is not in the grouping, because it's not grouped in parentheses together with x, that tells me up and down. So we put our cute little arrows next to it like this. So I know that all lines, at least in this assignment, are just going to take good old y equals x, they're going to move it up or down. Now there's other stuff you can do with it. Nope, I'll do it later. There's a lot of other stuff we can do with it, but baby steps. A parabola is the graph. The function is called a quadratic. Y equals x squared. There's grandma. Okay, that's the matriarch of the family. You call it the parent function. That one, we normally have x squared, right? Well, I'm going to do stuff inside the parentheses. or outside the parentheses. And the big thing behind this was outside parentheses, just like a line, is going to take that parabola, that U, and move it up and down. But the minus h is in the grouping. This is kind of a big concept here, moving further along in algebra. I think we'd use, like, if you're saving up to buy a new phone, you got to save up $800. You're working at your job. You're putting away $100 a week. It's 8 weeks until you get your phone, right? What happens when we take your input, your income, and oops, you got to pay $100 for your car insurance? Minus 100. Does your goal get closer or further away? Goes further away. Take that same goal, $800, 8 weeks, and now grandpa comes along and gives you $100 for your birthday. Does your goal get further away or closer? Plus 100 moves you closer. So please write these arrows. This is going to be bass-ackwards land. It's going to have the opposite effect because it's grouped in with x. If I say x plus 5, you ain't going right 5, you go left 5. Because I added something to my input. I'm getting to my goal sooner. Okay? I hope we all have that written in that blank space. Because you're going to be flipping back and forth to it a lot. Because that's kind of the entire assignment. Okay? Well, okay. Did we do these? We did? Oh, wow. We got further than I thought. So we were probably down here, right? Okay. Frank? Dude, don't. Okay. So I would look at it. I don't see any squared, so I'd say it's a line. Parent function is y equals x. And I see a plus 4 on the outside of my parentheses. So I go and look at my little cheater. My cheater says outside of parentheses goes up. Or it's up or down. It depends whether it's positive or negative. I'm going to go 4 units up. So if that's where we left off, I'd like you to fill in those other 3. Okay? Tell me, power of Christ compels you. Tell me, up, down, left, or right, what's the parent graph? Yeah. Okay. So it says plus 3, and it's in the grouping. You don't know, you got your arrows next to that one. So if it says plus 3 in the grouping, I go right 3.
Okay. So it'll just give this will be wait.
Or sorry, left 3. Left
So there's
3.
a square right here, so it wouldn't be just a line, right?
So it's x squared is your parent function.
Oh, okay. So just
So here I'll say x squared. What's that called? X squared stuff is parabola. Okay? You just keep coming back to that cheater. Yes, ma'am?
For this one, for like a function, because I have like the cheater stuff here.
Mhm.
So like, since would it still be?
The graph is called a parabola. The function itself is called a quadratic.
So this
I
would
will
be-
accept either.
So you would accept. I like x though. So hold on. So this would be a quadratic.
Quadratic.
That's a big word. And then
Quad. Rat. Ick.
And for these, do you put down, like this one would be 3 units up, 6 units up.
Look back here. It says +3 in the grouping. +3 in the grouping means go left 3.
Okay, so I would go
3 units left,
okay. And then this one would be 6 units left.
and then 6 is outside the grouping.
So it'd just be 6 units up.
6 units up. It's in or out, up, down, left, right. Dude.
Oh my god, this is my first day in this.
Okay. This is your cheater, right here. Okay, that's what all the stuff off to the right says. Or left. Sorry, upside down. So, first thing I do, I look at this. Does it have a squared or not?
No.
Which of those parents doesn't have a squared?
Mine.
So, I write the parent function of a line is y equals x. And then I did this to it. So, I go back to the line, and if it says +1, the arrow tells me I'm headed up 1. 1 unit up. Does it have a squared or not?
Yeah,
Which critter is it?
that one.
So, say the parent function of a parabola, or quadratic, I'd take either, is y equals x squared. They did this to it. Is it in or out of parentheses?
Out.
So I go to this stuff and say outside parentheses minus 3. It says go down. So I'd say I'm going to go 3 units down. That's it. Squared or not, line or parabola. Inside or outside, go look at your arrows. Okay? All right. 2. Does it got a squared or not? No. So is it a line or a quadratic?
No.
Okay. What does the line's parent function look like? Y equals x. And you check out that +1. Is that +1 in parentheses, left, right, bass, backwards, or out of parentheses, up, down, regular?
Up, down, regular.
So I will go 1 unit up. Look at number 3. Does it got a squared or not?
Yeah.
So it's you could do either. I would take either. Okay. The function is called a quadratic, but the graph is called a parabola. It's kind of like if I showed you a picture of a person and said, "What is this?" Someone could say, "Person." Someone else would walk up next to it and be a smart aleck and say, "Picture." They're both right, aren't they? Okay. So this is the picture, the graph. This is what the graph is showing. So what does the parent function look like, though? X squared. And then I got a -3. Is it in bass backwards left right land? Or is it in regular up down land? Okay, so it says -3 outside the grouping. I'm going to go 3 units down. 4. It's a quadratic again. Yeah. So the parent is x squared. And I got 2 transformations that happen to it. One of them, inside the grouping, I got a +3. So we go left 3 because it's bass-ackwards land grouped in with the parenthesis. I'm going to go 3 units left. And I've got a +6 outside the grouping. 6 units up. Okay, now I said these do get more complicated. Where's a Google Drive? Old math stuff. Slide pictures. Come on, Frank. You can do it. There we go. There. So, do you see the H and K stuff? Okay. That happens for any kind of function. That happens for weird stuff that we haven't even seen yet. Some stuff we have, like y equals x, the x replaces this f of x. Y equals x squared, we're doing these two right now. But there's also stuff like y equals square root of x, y equals x cubed. There's stuff like y equals the greatest integer of x. Yeah, that's a thing. Or y'all come back on Monday, y is absolute value of x. Okay, there's all kinds of stuff. And this is going to happen to every single one of them. Now, we are not going to see this or this. We're not going to mess with those. I'm just giving you the introduction, okay? Which is good because look at all the crap they do. We're just going left and right, up and down. So, you probably don't want those either. Flip it, go. All right, now, they do give us the function, but they also show us the graph so we can see what's happening. They're taking the original graph, the OG, version 1.0, right here, with every point on it. I suppose technically it's there. They're taking every one of these points, and to get over to this one, they're moving it 4 units to the left and 5 units down. And it's going to match perfectly. Okay? This is how we're going to get graphs in other places besides on that y-axis. Now I'm going to look at this. It says +4 and it's inside the grouping. So it's bass-ackwards. I see -5 outside the grouping. So heads down. I just write those real quick and say 4 units left, 5 units down. Easy enough? As long as you got that cheater, right? As long as you got that cheater written down, it's not a cheater, it's notes. If you have your notes with the arrows on there, you're just telling yourself how to do it. It's just looking for the pattern, looking for what's different about this one versus the original. So, real quick, 6 and 7, do them again, except now they're just taking away some of the other stuff. They're telling you this is the parent, this is the transformation. They're telling you this is the parent, that is the transformation. Tell me what happened. This is the parent, that is the transformation. I really wish they'd put like a comma or a semicolon, put something in between there. Yeah.
So for this one, I want to know if that is one letter. Wouldn't it be? Oh God.
Don't go by memory, just go look at it.
I mean, like, hold on. So it'd be right one,
Yes.
up one.
Yes.
Did I really just?
Yes. Now, how many of you are already sick of flipping back and forth and back and forth and back and forth? Man, wouldn't it be a good idea to just write that little cheater on a sticky note or a card or take a picture of it and just have that next to you as you're working? Right? Okay. Work smarter, not harder. Is there?
I want to flip this.
Mm-hmm.
So
So this is the parent. This is what we did. Minus 1 is in the parentheses. Minus means,
to the right.
so I go 1 unit right. Or right 1 unit, or however they said it. Okay. This is outside the grouping. Outside the grouping, it was positive 1.
Okay.
Okay. And then for lines, we switch it to, there's no real grouping. We're just going to go up or down. Okay? Mm,
No, don't go through my camera. There we go.
that'd be terrifying.
Yeah, I know. So I'm confused. So like, so it doesn't really correlate. Okay.
We put this next to x, right?
Mhm.
Is it positive or negative?
Positive.
Up or down?
Up. So, but like,
There's no parentheses, right?
yeah.
So I will not go left or right.
So it would just be
No units
so
left or
0,
right.
and then it would go up, 1, up.
Yep.
Huh. Okay, that makes sense.
Okay. So we look at the parent graph, or the parent function. We look at our little note card or whatever we're working with. I see minus 1 in the grouping. So I go 1 unit right. I see plus 1 outside the grouping. So I will go 1 unit up. It's that quick. The other one, maybe it threw you for a loop because they had 3 blanks there. Do you see a grouping at all? There's no parentheses. So if there's no parentheses, which is left and right bass-backwards land, how far left and right are you going to go? You're not, right? I'll go 0 units left or right because there's no parentheses. But there is a 1/2 outside of parentheses. And outside has that cute little arrow that says plus or minus, up or down. This says positive 1/2, so I will go half a unit up. Okay? Down below that. Oh no, words! Frank. Keep up, hey. All right, area of a square with side x is modeled by the function y equals x squared. This is bringing us back to middle school, probably the last time you saw this. Do you remember something like this? and then seeing those little tick marks to say that all the sides are the same. Okay? And I find the area of any rectangle by doing length times width. Well, if the area of any rectangle is length times width, but all of them, length and width, are x, that's x times x. And one of the very first things we did in this class, how do I simplify down x times x? Ooh, I know what I'm putting on our next test. Y'all remember exponents? X times x is x squared. Okay, so I can say a of x is x squared. I could say y equals x squared. If you add 10 square feet to the area, you get this guy. Describe the translation. Wait. Describe the translation. Describe the... That just means that all of this was practically useless. They just said y equals x squared plus 10. Describe the translation. So, is it inside or outside grouping? So is that up, down, or left, right? Okay, so this is in up, downtown. I go look at my arrows and they say positive is up, negative is down. So my translation will be 10 units down. That's it. Flip the page.
Why is it down?
Did I say down?
Yeah.
Oh, for crap's sake. Y'all, I've been up since 3:45. Okay. You had a choice.
Nope.
Is that getting any better?
What? Sorry.
Is that getting any better?
You put it on the wrong one.
I told you I'm tired.
That's another one.
No, it's not. That's not a mathematical error. That is a spatial perception error. Okay. All right. Flip the page.
You put it in the... Oh, no.
Don't you start too. Okay. Flip the page and you see your assignment. Okay. So what I'm going to do. Yeah, those two. Right? Or is it three? We did the word problem. Yeah, you got 9 and 10 at the bottom of this. And then the back page through 20. Okay? 9 through 20. Here's what I'm going to do. The other class is a little behind on stuff because they've had 2 late starts now. And no, you had the snow day, so you just missed. They did this stuff yesterday, but they did it on a late start day. Okay? So they got just enough time to get through stuff and had like 10 minutes to work. So instead of us pushing forward, since most of you have been taking care of business, I'm going to say, you show me this completed, we're good. Okay? Now you can work together